Hey everyone, welcome to your Friday lecture. I'm sure some of you are probably a bit tired at this point, having just finished assignment 2, but we're good to go with the Friday afternoon lecture. So let's get started. Go through the slides here. First of all, I just want to make some administrative points here, and that is, with respect to assignment 1, you should have just finished that. Remember, you get marked on whatever was pushed to GitLab at the time of the deadline, which was 15 minutes ago. You must have done the originality statement. I don't actually have it on the slide here, but you also need to have done your pledge. If you didn't do your pledge way back in lab 1, you won't get a mark, okay? You get no mark until you've done that pledge, and you do get no mark until your originality statement. Hello, is the one which show as week 4? I don't really quite know what you mean. What's the confusion there? Oh, week 4. Okay, my MS stream title is wrong. Sorry, my bad. All right, no worries. This is week 3. Someone's worried that it says week 4 in the streams on MS stream. Ignore that. Okay. Anyway, let's get on with this. I think you all know it's week 3. The originality statement is essential, and you can't get a mark without it. So if you forgot to push that originality statement, or you made a mistake, say you forgot that you got a little help from someone, you've probably got a few hours to fix that up, okay? So if you're one of these people who accidentally got some help and forgot to put in the originality statement, now would be an absolutely awesome time to fix that up, and you can do that without a penalty, okay? But if your tutor has to go and chase you and ask for the originality statement because you didn't fill it in, you will get no marks. And of course, you can't pass the CI without it anyway. Your marks, once the tutor has marked them, they'll be on streams, and we hope to have that to you by the end of next week, okay? You'll get a few sentences of feedback from your tutor. This isn't just worth 5 marks, remember? So you get a small feedback from your tutor as well as auto grading and some manual grading on the assignment. Assignment 2, does getting help from tutors need to be marked on the statement? No, I answered that on PR, so you don't need to. The originality statement doesn't have to include help from tutors. Assignment 2 will be available to you next week, and we should have that ready for you before your first lab. And in your lab next week, everyone will get put into groups of 3, and you'll start assignment 2, which takes up the rest of the semester. Course representatives. Let's go to the web page. I'm very pleased to say we now have class representatives. I haven't done a reload of this page. This is the course web page, and you can see here something I've written about the course web page. Class representatives are a fantastic resource. They really are, but they're no substitute for providing feedback to me. Okay, so if you've got an issue, something you're not happy with, or something you are happy with, please tell me directly. Okay, if you can't tell me for some reason, that's not good, okay? But that may happen, right? And if that happens, then you need to tell your class rep, okay? And you need to explain to your class rep why you didn't tell me, okay? If you're feeling like you can't tell me stuff, that's actually important feedback in itself, okay? So we want you to tell me stuff first, okay? So I've asked your class reps that the first thing they will ask you is, okay, you've got this feedback. Did you tell Steve yet? And if the answer is no, then they're going to be interested to know what the reason is, right? And if it's because you find me unapproachable and so forth, that in itself is really useful feedback, okay? And this is something you should be doing in every class, okay? Class reps aren't there to gather independent information from what you're going to tell your lecturer. You should be telling them both the same information, and you should tell your lecturer first. Otherwise, how are they going to fix stuff? Okay, so please do that. And this is a very real issue. I've taught for quite a long time at ANU, and this is the way it works really well. And it works really well if you guys have a good relationship with your class reps, and I have a good relationship with them too, and I work really closely with them. All right, and I've already got great feedback from some of your class reps have already given me awesome feedback, so I'm really pleased about that. Now let's do a reload here. There they are. There's our class reps. Here they are. So we've got Wenhan, we've got Linda, and Xiao. Okay, or Sean. Okay, so we've got 3 of your class reps there. The photographs not so handy during COVID, but normally you'd go and walk up to them after the lecture and see them, or see them in labs and stuff. But anyway, there you are. That's your your class reps, and you can see them on Piazza or email or whatever to catch up with them. And they're all really awesome students in this course, and they're really dedicated to making this course better and making your experience good. So please make use of them, but please also remember, you should always come to me if you have an issue, and if you can't do that for some reason, that in itself is a worry, right? I don't want that to be the case. I always want you to feel free to come and tell me the good and the bad. All right. Any questions about that? If you have any questions about the class reps or anything to do with that, just let me know. Now, next week, I don't know if I had this on the admin slide. Where are we here? Go on to PowerPoint. There we are. There we go. The Wenhan's already piped up on Teams. You should get to know Wenhan. He's one of your great class reps who's already on the ball, already helping out. And I'm going to make a habit. My plan is to meet with them for just a few minutes every Friday after the lecture. So, all right. One thing I didn't mention is that next week, those of you should all know that next week we have a hurdle assessment, which is the let's go to back to the course webpage. There is a hurdle assessment next week. Where is it? Assessments. Right here, hurdle assessment there. Week 4 basic competency assessment. It tells you about that here, blah, blah, blah. Okay, this, and there's Linda. Linda said hi on the chat too. So Linda's one of your other great class reps, and you saw her photograph and Sean's and Wenhan's photograph a few minutes ago. The basic competency hurdle. If you pass the lab test, then you don't have to worry about this. So the passing the lab test is a free pass on the competency hurdle. However, if you fail the lab test or get anything less than half, then you need to do the competency hurdle. And unfortunately, if you can't pass that, you will fail the course, which means you basically have to leave the course. Okay, right? So for everyone who passed it, that's all good. All right, everyone who passed last week's lab test, it means you got a free pass to the competency test, and so you don't have to do it. So the vast majority of the class, this is not important information, but for a few of you, this is actually really important information. So please make sure you get this sorted out. What else next week? Next week is a regular lab, but you'll form your new groups, which should be good. You get to meet your group mates and so forth. One other thing that I really wanted to highlight here, I put a post on Piazza that you see up here, 245 people viewed it. Everyone needs to view this, not just 245 people. Every person in the class needs to read this here, okay? There's a bunch of stuff here I said about academic integrity. I don't want to belabor it. I want you to just go and read it. But I do want to highlight one thing for you. And that is this thing here that we have a provision for at ANU, and I use it in this class, whereby if there's any reason that I can give you an oral exam on any assessment, and if the outcome of that oral exam is not satisfactory, that will override the other assessment. Okay, and so for example, with the lab test that we ran last week, I will be finding some people and inviting them to do an oral exam during the labs next week. And please understand that you need to be able to reproduce what you did in the lab test. If you can't do the lab test when I'm looking over your shoulder, then there's a serious problem. Okay, so I just wanted to highlight that for you. And of course, if you fail the oral exam, it means you fail the lab test. So for those of you who perhaps weren't acting with complete integrity during the lab test, just be aware that I will be probably approaching you and asking you to demonstrate what you did to me directly, okay? So I just want to give you a heads up on that. This is not new to you. It's in the course webpage, it's on the ANU rules, and it's on this Piazza post, so it shouldn't be a surprise for you. But I just wanted to let you know, for those of you who didn't do the right thing, that you can expect me to catch up with you next week and have a little chat. All right. Now, I think that's it. So that's all the yuck stuff. Anything else? We've got Linda and Wenhan vying for the most number of hearts and thumbs up. Good to have two enthusiastic class reps already on the board there, and I'm sure Sean is not far away. I think we're ready to start with our next piece of the learning. And for those of you who are feeling exhausted, having just finished the assignment and so forth, you're doing great. We're through a huge chunk of the course, and remember, the whole reason why we're doing this is to lay the foundation so you can assign the major part of the course, which is the group assignment. That's the main part of the course, and you're going to find out about that next week. And having gone through all the stuff you've done, the lab tests, the lab exercises, the homework exercises, and the assignment, having done all that, you're in a great place. If you've done all that yourself and you're getting a pass in that, you're actually in a great place, okay? And remember, if you're not getting a pass in it, don't stress, because almost all those things are redeemable, all right? Now, onto this next part here. The reason why I had that digression there is just to point out we're actually going through a huge amount of Java, but we're going to keep repeating stuff. So those of you who think like, oh man, I'm so far behind, don't stress. We're going to be repeating stuff. So someone says the deadline is passed. We'll be able to use the CI to test it. Don't change your assignment now that the deadline is passed. But one of the reasons why we had this hard deadline is that once the deadline's passed, people can share their assignments. If you want to discuss it with other students, you can, and so forth, once the deadline's passed. And of course, that means I can't accept any late assignments, but you can share it if you want to talk to other people about how you solve the assignment. That's fine, right? You can still use the CI, but please don't push any changes to your assignment in the next little while, because your tutors are accessing it and it could cause conflicts and stuff. So it's better not to touch your assignment now, unless your tutor tells you because you've made some error. All right, with that, let's get on with this next module. We're going to go to the next step on inheritance. Now, hopefully some of you will remember what we did on Monday. Can you all remember what we did? We did animals, right? We did all those, the relationship between all the animals, right? And we looked at snakes and whatever else. Now we're going to do one more small step on that. That took a long time to go through that. We're going to do something much quicker in this little unit here. And we're going to go over a few more key concepts in inheritance, which is one of the key ideas in object-oriented programming. By the way, I'm just going to quiz you one more time on object-oriented programming. What are the two concepts? You can write your answers on the chat. What are the two key concepts that an object embodies? It embodies two key ideas, an object in an object-oriented language. There's two things. It embodies, you guys should be able to rattle this off straight away. I'm hoping I'm going to see something on the chat. I don't see anything there yet, but anyway, it embodies state and behavior. State and behavior, they're the two things. Yeah, perfect, great. Behavior and state, yep, that's passable too. State and behavior, all right? And that's great. So you need to remember that, because we keep coming to that, and that's a key fundamental idea. It's actually a really simple idea at some level, but it takes a while to get that in, right? And it's very different to other styles of programming, like functional programming. All right, so remember, I've said many times, and I'll repeat it again, in Java, we have single inheritance, and the thing at the top of the hierarchy is java.lang.Object, right? So you see that over there on the screen, java.lang.Object is at the top of the hierarchy. And everything inherits from that. And as I've said before, in English, we would use the word thing as just a very general word for an object, okay? In Java, we say java.lang.Object. And so everything is of type thing, or java.lang.Object, but it might be a more specialized kind, okay? Now, there's Sean, okay? So Sean's introduced himself. He's another one of the class reps. So say hi to Sean there. So you've now got all three class reps saying hi, and you can say hi to Sean. Now, because they inherit, it means that anything that is implemented in the higher up in the hierarchy is inherited. That's the word inheritance, inherited by the ones below it. Okay, and on this screen here, I've listed a bunch of things that are implemented, methods that are implemented by java.lang.Object. There's a thing called clone, which allows you to copy an object. We won't use that in this class much, but there you are. It's one of the things it has. Equals, which is an incredibly important idea, and it's used to establish equivalence. And it says this object is equivalent to this object. They're not the same object unless it actually is the same object, but they mean the same thing. So you could have two integers, and this is 375, and this is 375, and they're both objects, not ints, but integers. And you could say, are they the same? If you say double equal, like equals, it'll say, no, they're different objects. They're not the same objects. But if you use the equals method, it says, this has the same essential value as this one. They're equivalent. And that's what the equals method is doing in Java.lang.Object. And every type has this. Every object has it because it's in Java.lang.Object. Finalize, we're not going to go into that in this course. It's actually not a really cool idea, but it's a troublesome idea, which but it's one of the key ideas in the early versions of Java, and that is the idea that you have a method that gets called when an object dies. And why might you want to do that? Well, maybe the object is holding onto a resource, and so when this object's no longer useful, you want to get rid of that resource. So maybe a file is open or something like that, and you say, okay, this object's no longer reachable, then let's get rid of that file. So you can have some code that runs when the garbage collector decides that, the GC stands for garbage collector, when the garbage collector decides that this object is no longer reachable. Okay, and get class. You know what that is? We already used that last in the code when we wanted to find out whether something was a eastern brown snake or a redback spider. We had get class, and that told us what class it is, because we didn't know, because it just said animal or something like that, and we could say, oh, is this, which type is it, which class is it? And the get class method is something you can call on any object, and you can find out what class it is. Okay. Hash code is an interesting idea. We're going to use that a lot later in this class. It's not very important at this point in the class, but later in the semester we're going to use that a lot. And that's that returns something like a random number. It's not really a random number at all, but it's attached to that object, and it'll always return the same value for that object. Okay, it's like a unique identifier, if you want to think of it that way, like a student ID or something like that. It's a special identifier for that object. Okay. We call it a hash code. We'll discuss this in detail later, but because it's implemented in java.lang.Object, it means that every object has a hash code method. And finally, one that you have seen me use lots of time is a toString method, and that represents that returns a string representation of an object. And you know the default version of toString is not very pretty, and so very often one of the things we do is when we make a new type, we write our own version of toString, so that when we print this object out, it looks more easy to read. Okay. The final hash code is not what's compared when you do object equivalence. That's actually different. That's actually comparing the actual object, the address of the object. So no, it's not that. 04 has some uncovered array list. I have mentioned array list already in class, but not in detail. We're going to do it in much more detail later. Okay. So yeah, we're definitely covering array list. We cover array list. I'm reading questions off chat. We cover array list in great detail in this class, and I didn't realize it was in homework 04. But if it is, don't stress. We're going to go into that in great detail later. In fact, you guys later in semester are going to build your own array list from scratch, okay, as well as using the one that Java provides you. The final keyword is, now here's the key concept, some more key concepts I really wanted to drum home today, and we're going to apply these ideas to the stuff we did on Monday's lecture. If you think about that hierarchy, we had what at the top? We had java.lang.Object, and I think we had animal, then we had something like reptile, we had fish, we had mammal, and then down at the bottom we had things like dog and eastern brown snake, which was specific. And if you want to think of that as a tree, these were leaves of the tree. They were the end of the tree. Now, the final classes and methods, final is a keyword you can add to a class. It says no one can make a subclass. Okay, so we could decide, for example, that there's nothing more specific in terms of the animal hierarchy than an eastern brown snake. Okay, I don't know if that's actually literally true in biology, but let's just say it is. Then it says, okay, we can make the eastern brown snake class final, which means no one can subclass it. Okay, because we're making it very clear this is it can't be further refined. All right, you get that? So a final keyword on a class says this can't be further refined by another class that inherits from it. This class can't be inherited from. No one can inherit from this class because it's the end of the hierarchy. It's a very specific thing. No one can inherit from it, and that can be a useful thing to do sometimes. Okay. The final keyword can be applied to a method. So that was for a class. For a method, you can do it to a particular method, saying, okay, you know what, this method which I'm defining for all reptiles is final. So specific reptiles can't change this method for some reason. Okay, so all reptiles have the same implementation of this method, and I can ensure that by declaring it final, and that stops anyone from overriding that particular method. Okay, so if the final keyword existed on toString, then it would mean we could never change toString because it was final. But it's not, of course, so we can change toString. All right. Next, I'm getting distracted by the questions there. I might come back to them later. The next key idea I want to introduce is kind of the reciprocal. It's the other side of the coin. Final is when you're at the end of the hierarchy. Abstract is when you've got an idea which is not actually something you can make a real thing of. You really want to be more specific, and you want to prevent people from making a thing like this. Okay, and an example is you might say an animal is an abstract idea. Okay, an eastern brown snake is specific, but an animal is abstract. Okay, I can't just create an animal. I create a specific animal, like an eastern brown snake, okay? And so if that's true and we want to enforce that, then we say, okay, animal is abstract. You can't go and make an animal. You can only make something which is a subtype of animal, something more specific than an animal, such as an eastern brown snake or a great white shark or something like that. Okay, an abstract can also be applied to a method that says that the method is declared as abstract, which means that the subclasses must provide an implementation of it, which is kind of the opposite of final, which is saying that subclasses cannot provide an implementation of it. Okay, so if you don't have these keywords, either can apply. But if you have abstract, it means the subclasses must have an implementation. Whenever someone implements this, at the end of the hierarchy, someone must have implemented this thing. Conversely, if you declare something to be final, it means no one below us can implement it. Okay? All right. Time for the mini quiz. I hope that made sense. And then we're going to write some code. Let me go to this mini quiz here, publish it. There it is. Hopefully you can all see that. And now we're going to get on and write some code. And here it is. What we're going to do is open up a new package. What I want you to think about, hey, many asking on Piazza right now about sharing solutions, posting solutions to assignment 1. Do you have such a plan? Well, I've already announced that, folks. I already said that anyone can share. You can share your work, right? I'm not releasing a solution. I never do that, okay? I don't like the idea of a model solution to any task, okay? But you all can compare notes and say, hey, here's a great way to solve it, or here's a really bad way, this didn't work, or whatever. You're absolutely welcome to do that. I said it a few minutes ago in the class. Once the deadline is passed, no one can submit new work. It's all free. You can all just go and share your ideas with each other. That's perfectly okay. I can't go to Piazza right now and answer it myself, but there you go. All right, hopefully that clarified the answer to that question. Okay, 05. All right, let's go here to 05. And what we're going to do here is, this is a question I want you all to think about. I'm going to start typing in a few minutes. And what I want you to do, if you can go ahead of me, is go for each one of these things and type in the chat the name of the thing, like albatross, and then tell me if it should be abstract or final, okay, or nothing, right? So for any of these things, starting at the top of the alphabet, go into the chat and say, should this thing be abstract or final? And what we're going to do is going to change these classes to be abstract or final. Remember that an abstract one is one that no one can really make, and I'll give you a hint. An animal is an idea, not a concrete thing, okay? So an animal would be abstract. On the other hand, eastern brown snake, you can't be more specific than that, at least in my view of biology. A biologist might beg to differ. You can't be more specific. Therefore, we can make the eastern brown snake final, perhaps, and make the animal abstract, because no one can actually make one. All right? Now, there may be some cases here that are borderline. That's okay. Not everything's always clear cut. But hopefully you get the idea. So you can start typing away in the chat. What I'm going to do here is take this code and copy the whole lot there and dump it into 05, like that. Bang. We've copied the whole lot into 05. There it is. Add. All right. So now we've got a new version. That was Monday's lecture in 04. And the only difference with today's lecture is we're going to go here to every class and simply annotate it. Yeah. And someone's already said that the albatross is final. Okay. And we'll put the word final in here, like that. Okay. So that means no one can make something more specific than an albatross. Animal, we'll make that abstract. Okay. Because we don't want people creating an animal. It's an abstract idea. It's not a concrete idea. Okay, so we'll say abstract, like that. And then arachnid. What's that? Anyone have arachnid? Okay, that is an idea. It's not a concrete thing. An arachnid, for those of you who don't know your biology, that's like spiders and I think scorpions and things like that. Okay, so we'll say that one's abstract. Okay. And then a bird. A bird, that's also abstract because it's not specific at all. Okay. We'll say a dog is final, but really, you know what? We might say, you could argue the toss on this one because you could say, well, there's Dalmatians and Dachshunds and German Shepherds, but for the sake of, we'll make our biology very simple for this class, and we'll just pretend that you can't be more specific than a dog. Okay, now, one thing, if you've got very sharp eyes, let me see if I can do this on my Mac here. Not with the way I'm doing stuff at the moment. No, I can't. I'm trying to amplify that there. I can't easily do it. Let me just try one more trick here. Nope, not happening. All right, if you do have sharp eyes, you can see here the symbol has changed. If you look at these symbols, here they're just circles. And if you look at dog, it's now got this little thing there which indicates that it's final. And bird has got these little bars on the side, which means it's abstract. When you get my code from GitLab later, you'll be able to look for yourself. But IntelliJ is drawing these logos differently according to whether they're abstract or final. All right. So now what we're up to? Did dog, eastern brown snake? I already gave the answer to that one, didn't I? It's final. Right. And then fish. That's a general idea. So that one's abstract. What do you all say? Yep, abstract. Very good. Yep, it's an abstract idea. Fruit bat. That's concrete. So we'll call that final. Now, some of you might argue with my biology, and that's okay, but for the sake of this class, I'm going to call it final. Likewise, a great white shark, the very specific kind of fish. A human, final. And we'll go back to mammal. Mammal's definitely abstract. It's a whole category of things. It's an abstract idea. Okay. And monitoring, likewise, it's an abstract idea. Platypus is final, definitely final. There's nothing more specific than a platypus. And redback spider, that's final. And reptile, that's an abstract idea. So the snakes inherit from that. Okay. Abstract. There it is. Okay. And venomous is an interface. That's a different category altogether, which we covered in the lecture last time. And that's basically it. One last thing before we finish. I just want to point out to you that you cannot create, if we say animal, animal, so we declared a variable of animal, and I could have said something like this. I could have said new great white shark, say. So Sue's a great white shark. That's all good, right? No problem with that. Until I've got to give it a name and everything. So Sue. Right, whatever. Okay, so I can create. Notice animal is Sue. We're describing Sue generically, but we're creating a specific kind of animal, which is a great white shark. What I want to demonstrate to you is we can't do this. Okay, if I try and create an animal, we've got this red squiggly line there, and it says no, you can't do that because it's abstract. You can't make an animal. You can make a great white shark, fine, but you can't make an animal. All right. So I just want to demonstrate that you can't do this. All right. I'll just put a comment there, so when you see the code later, you can't do this. Animal is abstract. Okay, so if you uncomment that, you'll get the red squiggly line. So you can't create objects of abstract types. Okay, I can't create an animal. I can create a great white shark, which inherits from animal, but I can't create an animal. All right. And if the error message was very clear, let's just go back to it and see what IntelliJ says. It says exactly what Adam has said there. I think it's almost word for word what he said. It says here. Let's hover the mouse over it. Right. Animal is abstract. You cannot be instantiated. Okay, it means you can't call new and make a new one of these. All right, so I'll comment that out and we're done. Okay, so we're done with this whole unit. Hopefully you've got this idea now that about inheritance, a much richer idea of inheritance than what you did at the start. And hopefully this little example here with this hierarchy of animals and the idea that some of them, like java.lang.Object's right at the top and it's obviously abstract, and then right down the bottom you've got things like the eastern brown snake and the redback spider, which are and the platypus, which are very, very specific. Okay, and things in the middle which are classes of animal. All right, or categories of animal. I use the word class in the English sense of the word, not the Java sense of the word. All right, I think we're done there. Let's move on. Next, we're doing something fun. I find it fun anyway. We're doing JavaFX, and this is relevant to your next assignment because in the last assignment we gave you all the code for the graphical user interface, and you noticed there were a few little bugs in it here and there, but some of you noticed on PRs and reported small bugs and so forth. But it's a complicated piece of code, and we gave that code to you deliberately as an example of how you might do some funny things. And I think if you look closely, you should have found there are some odd things in that class that are there just for fun. Like I think if you press a certain button, it'll play a tune, and if you press something else, it'll do something else. Okay, there are a bunch of different things in that code, and the reason for that is so that you can use that code in your next assignment. So you're allowed to use the assignment 1 code that we wrote for you. You can use that code when you write your next assignment, okay? But you're going to have to do some JavaFX work in your assignment, okay? What is JavaFX? It's designed for rich client applications. It's designed for graphics, user interfaces, audio, and video. It's got Java APIs, and it's not bizarrely enough, if you do a web search for JavaFX, you could accidentally find a thing called JavaFX 1, which has nothing to do with JavaFX, the later versions of JavaFX. It's not even the same language, okay? It's some strange scripting language. Okay, so when you look for JavaFX, do make sure you're looking at Java, not this scripting language called JavaFX 1. It's bizarrely got the same name. Frustratingly, Oracle decided to remove JavaFX from the distribution of Java. So from Java 11 onwards, it's actually a separate thing, and you've already been through the hell of installing it and setting it up correctly. I really don't understand why Oracle decided to do that. It was an awful lot easier when it was actually just part of the standard Java install. Anyway, it replaces previous graphics libraries in Java, such as Swing. And you saw a little Hello World thing in Lab 1 where you said Hello Tutor. That was an example of a JavaFX application. And we're going to walk through something in this class where we do that. Okay? Oops. Where are we? There we are. Key ideas. There's some very, very key ideas here. Every application that uses JavaFX must extend this class. Okay? So it's a subclass of JavaFX.application.application. Okay? So you have to have that there. If you have that, if you make a thing called Hello World that extends this, then it's a JavaFX application. If it doesn't extend this, it's not a JavaFX application. Okay? And then that application will have a thing called a start method. And someone asks about what's the difference between an interface and an abstract class. All right, I'm going to push pause on JavaFX because that's such an important question. So I'm going to answer James's question. There's a very big difference between an abstract class and an interface. They do look the same in some respects, but there's a key idea. Think about the running example I keep giving you about interfaces, the movable thing, okay? The key idea there was, the reason why I gave you this crazy examples of an airplane and an elephant is because they have no inheritance relationship. There's no relationship between an airplane and an elephant. The only thing that's relatable is that they might implement the contract that says, yes, we can move, okay? Right, and so they both could implement the interface that says movable thing. So I can move, and anything that is a movable thing could implement that interface, even though they have no conceptual relationship. All those things we did in the example from the last lecture and today's lecture have conceptual relationships. There's a relationship between the eastern brown snake and the idea of a reptile. Okay, there's a relationship between a reptile and an animal. There's a relationship between a human and a mammal, and so forth. Okay, they have conceptual relationships that are real-world relationships that are useful for relationships when you're building something. Okay, there's no conceptual relationship between a bicycle, an airplane, an elephant, and a horse, except that they happen to all be potentially used as modes of transport. That's the only relationship, but they don't have a natural single hierarchical relationship. So what we do is we use interfaces to say all those things can implement these properties that we associate with transport. Okay? Let me get back to JavaFX. That was a digression. I was responding to a really key question on the chat there. So JavaFX. Okay, key idea is a stage. They use these metaphors. You know, you guys are getting used to the idea of using metaphors here. They're using the metaphor of a stage, you know, a stage like in a theater. And that is actually the window that you're familiar with in Windows, Mac OS, Linux. You got a window, right? And it's got little buttons on the top left for making it bigger and smaller. And you've got that sort of stuff. They call that a stage, all right? So, and that is operating system specific. So you say, give me a new stage, and what that does is it creates a window according to your operating system. So if you create a new stage in Windows, you'll have the decorations you're used to seeing on a Windows window, and if you do it in Mac OS, it'll have the decorations you expect in that particular version of Mac OS. All right, that's a stage. A scene is something you put on the stage, just again following the theater analogy. A scene is something you put on the stage, and you can take it off the stage and put it back on the stage, okay? Scenes, you can put multiple different scenes on a stage, okay? The next idea is the idea of a graph of objects that form a scene. most of you probably have used a tool like PowerPoint to do drawings, or Illustrator, or any of these things that have all the circles, and you can make groups of circles and so forth, or groups of objects. Same sort of idea here. You can have a hierarchical relationship of a whole lot of these things, and that's called a scene graph. Okay, scene graph, and you can make this thing be a group, and you have this thing laid on that thing, and so forth and so on. Very much like those tools like Illustrator or Photoshop and so forth. All right. What is a node? A node is an object or a group of objects, just like I just said. So it could be a rectangle, that could be a node, or it could be a group of objects, okay, which contains a rectangle, okay? Just like in Illustrator or whatever, you can have a group that behaves very much like a rectangle, and a rectangle could be inside a group. We call them nodes here, okay? A pane is like a window pane, and it's a way of organizing nodes in a scene graph, okay? You don't have to worry about operating systems in the assignment. Besides, everything gets assessed on the standard environment. But yeah, JavaFX supposedly deals with all of this. If you do something really weird, you might run into an issue, but you shouldn't need to worry about it at all. Okay. JavaFX scene graph, a tree of nodes. Yeah, I just mentioned this. Okay, so you've got a group here. You've got a group which contains a circle, a rectangle, and a region. The region contains a text and a thing called an image view. An image view, for example, is actually like a graphic, like a JPEG or a PNG. All right, and you can see this is the idea of leaf nodes and branch nodes. Okay, so this hopefully is relatively familiar idea to you just from applications you've used for drawing on computers before, which has nothing to do with Java particularly. So that hopefully those ideas are not too foreign to you. You can set properties of a nodes programmatically. So you can say, here's a message. You can create this message called hello, and you can set the font. You can make the font a particular weight. You can make it red and so forth. And you can also use it declaratively using CSS. Okay. Now, we don't go into the CSS stuff in this class, but it's there if you're interested. So now let's go to the mini quiz, and then we're going to get to write some code. So let's do that, which will be fun. Okay, the mini quiz should be open for JavaFX, and let's us all move to writing code. So we'll collapse that down and say goodbye to all our beloved animals. I won't close them, it's going to take me an age. And I'll create a new package here, new package, and we'll call it X01. X stands for JavaFX. All right, X01, and inside that we're going to create a new class. And I'm going to do some tedious, boring stuff at the top. You need to do this every time you write an application in JavaFX. So just watch this. People often ask, is JavaFX actually examined? I won't in any exam ask you to write JavaFX code, okay? And the reason why is because it's really annoying to examine with auto grading and stuff because it's visual, okay? So you can be assured that when you sit an exam, I might ask you a question about JavaFX, but it won't be, it'll only be like a true-false question or something like that. I'm not going to ask you to write code in JavaFX in an exam, all right? So let's write this in JFX hello. No, that's not what I wanted to do. We'll jump the gun here. I want to do JFX square. This is super exciting. We're gonna draw a square, folks. JFX square. And we're gonna add to get. Yep. Now the first thing we're gonna do, and I said this to you before, is we need to extend this particular class application. Okay, I'm just gonna write that. I'm gonna let IntelliJ help me out here. Maybe. What's it gonna do? What have I done? Extends. I didn't write extends. That's why it's not helping me. Extends. Okay. Now it's going to say which one do you want to extend? Oh, no, I haven't spelt it right. Still not helping. Okay, there we are. There we go. Do we want sun? No, we don't want that one. So what we need to do is we need to press this. Oops. Sorry, keyboard issues again. There we are. We get to choose which one it is. Very important, folks. Notice how there's two applications there. We want the JavaFX one. We do not want this one, okay? So we're choosing this. Sun is the old company that Oracle bought. That's an old thing up there. Instead, we want this one, okay? So that's what we want. Import JavaFX application.application. We could have written the whole thing out. We could have typed all this in, but I just wanted to show you how IntelliJ will do the autocomplete. If we got that wrong, it would have had the wrong import here and things may not have worked, okay? What did I press? I pressed enter. I pressed on this keyboard. It showed you the prompt, right? If I go back, let me undo. Okay, see that? It tells you what to press, and that little logo, that little icon there is the Mac icon for the Option key and the Enter. That's what it says on the screen there. Press Option and Enter, so I do that, although I've got a weird Windows keyboard here. I do that and it brings up this menu here. I choose which one I want by the up and down arrow, and then once I've found the one I want, I press Enter, and then it does all that, okay? Now it's got an error message. What could that be? All right, well, we need to implement the methods we haven't implemented, right? And we do that, and it puts in this method here. We have to put that method in because that is a method that every class that extends this application has to implement. So we do this, and we have to write a bunch of stuff in here. Notice the argument we get is a stage. What's the stage? Can you remember what it was? The stage is like the operating system window. And the first thing we're going to do is set the title at the top of the window frame. Notice up here it says COMP1110 lectures. This is a Mac OS Windows. It's got these little icons there. That's what Mac OS does. If you do it on Windows, it'll come up different. If you do it on Linux, it'll come up different. But they all have this notion of a title for the window. That one's there is called COMP1110 lectures. So we can set the title on our window. We do this. We say stage.set title. IntelliJ is great for completing this because there's so many options, and it will often guess the right one and give you a bunch of options to choose from. So we're going to call it square because that's the name of this program. It's a very boring program, but it's going to draw a square. And so we're going to put square. The word square is going to be at the top of our window, okay? Now, here comes some template GORP that you just have to do. Just do it this way. You have to create a group, which is the root of the scene. So you've got to create a scene. We're going to make a thing called a scene, and in it is going to be a group of objects, okay? So we create a group first. Group, and we're going to call it the root. Doesn't matter what you call it. Now it's asking us if we want to import the right thing. We do. We want to make sure it's a JavaFX group. There it is. We've included the right one. It's very important to include the right one. We've done that. We've got a root, and we're going to say that is equal to new group. Right? Very good. And it's JavaFX is doing a lot of autocomplete for us here. So we've created a thing called the root. It doesn't matter what we call it, but it's a group of objects, okay? It doesn't have anything in it yet, but it's going to be a group of objects that are going to go in our picture, okay? Then what we're going to do is going to create the actual scene that's going to go on the stage. So it's a scene. There it is, JavaFX scene. Scene equals new scene. And now we've got to pass it some arguments. We've got to say how big the scene is and what objects are going to go in the scene. And the way we do that is we say root, there it is, root, comma, 300, oops. And by the way, on the course webpage, Leo's just added some docs in there. Note there are also a bunch of references on the course webpage. When you go to the course webpage, you go to lectures, you will find JavaFX. Where are we? JavaFX. You go here. It's got a bunch of documentation here. Okay, you've got links to the tutorials and stuff that they have. It's worth going to those if you're interested. Okay, so what that's done is said make a scene. And make it 300 by 300 pixels. That's not very big. And then what we can do is add that scene to our stage. Stage.setScene. I think it is, yeah, set scene. And we're going to pass it the scene. Okay, so we've made a scene and we've put it on the stage. So now it's on the stage. And if I run this, what's going to happen? Let's have a look. Let's see what happens. Where are we? Where's our program? Down here. Okay, we'll run this and let's see what happens. Okay, run. There it is. Waiting. Okay, still waiting for the thing to come up. Where is it? Okay, nothing came up. Why did nothing come up? Because I forgot something crucial. I forgot to do this. And if you don't do this, nothing happens. And you'll sit there thinking, why isn't this working? You must do this. You must show the stage. It's like raising the curtain in a theater. If you don't do that, you get nothing. All right, stage.show. Oops, stage.show. Okay, so show the stage. There it is. Okay, so you've got to show the stage. Let's run that like this. We'll do it again. Oops, stop that. It was still running, but it wasn't doing anything. Now we'll do it again. Okay, and we've got ourselves a window. And that window has a title called square, which is what we said. And it's 300 pixels by 300 pixels if you go and measure it. Okay, great. But that's all we've got so far. Now let's add something to that window. No, you can't use swing. Swing's a deprecated thing. We don't use swing, use JavaFX. You have to use the right libraries. So no, you can't use swing. We're going to create a rectangle. Rectangle R equals new rectangle. We're going to make a rectangle. We're going to put a red rectangle inside of our window. Okay? Rectangle 100, 100, 100. And you'll see in the assignment, it's very specific. You have to use JavaFX. And so, okay, so I've made a rectangle there, and what I've said is that rectangle should be 100 by 100, right? And remember the window is 300 by 300, so it should be, if we said it's going to have the top left corner at 100 by 100, it should be right in the middle of our 300 by 300 rectangle. Now, to make it easy to see, we can change the fill color by set fill, and then give it a color, and we'll give it red. Color, there it is, color, JavaFX. Well, I have to get the right one. Color dot red. Say it could be any color you want, right? Now, why is that coming up red there? What's that all about? Rename reference. What? Why is that unhappy? I don't know what's going on there. Hopefully it's not important. I don't really quite follow what happened there. Rename reference. Error, cannot find symbol. Set fill. Oh, I've included the wrong type of rectangle, I bet. That's what's happened. Where is rectangle? It should be, that's odd. Rectangle's not there. It should be, I don't even see rectangle there. It's peculiar. Okay, so why did it not do that? That's interesting. So we didn't import the right thing for rectangle. That's a very strange error. I've never seen this before. Oh well, you're learning. You're watching me make an error. Well, I didn't really make the mistake, but I guess I did. But I'm not really sure what's happening here. So what we're going to do is we're going to explicitly include the rectangle, which is a shape rectangle. Okay. Now everything's happy. I don't know why it allowed me to put that rectangle in without actually saying what type it was. You imported AWT. Oh, it's down there. Okay. Perfect. I didn't see it because it was grayed out. Thank you. You're absolutely right. So I accidentally imported AWT, which I should not have done. This is a real hazard. It actually, there's lots of different libraries you could use, and JavaFX is one of them. And it often includes the wrong one, which is not helpful at all. Okay, so now if we run this, we should get a red rectangle inside of a white square. Let's see this. Oops. Oh, we forgot to add a rectangle to the scene graph. That's very, very important. So we have to say root.getChildren.add, add R. Okay, we're going to add our rectangle R to our graph. Otherwise, we're creating the object but not doing anything with it. Now we're going to the root, finding all of its children, adding to that set of children this thing here. Run it again, and we should see finally see our window with a red square in it. Okay, terrific. Now what we're going to do is a small variation of this. We're going to do a very quick cut and paste, copy, paste in here, copy, hang on, wrong keys, there we are, paste. We're going to call it JFX Hello World, like that, add to Git, yep. And I've accidentally typed in that somehow. I don't know how I did that. Same in here. It's going to be, I guess. What's the matter here? Yep, got that stray character got typed in there by accident. Okay, so just being lazy, I just copied that code over. If we run this thing here, we just get the same red square, which is extremely unexciting. But what we're going to do now is we're going to put some text in here and show you a couple more things you can do. Okay, so that's our square. Let's get rid of the square. Okay, and get rid of all that. Now what we're going to do is add some text. And what we're going to do is going to write some text here, like text, and make sure we get the right one, not an AWT one or something like that. There it is, text, and we'll call it hi equals new text, right? And then we have some text here, like hello world, like that. There it is, some text. And then we can do stuff with this. We can say, we can set the font, and we can say the color and all that sort of stuff. Get Children says this is a group here, and a group contains other things. And we're going to say, what does it contain? And it's got a thing called like the container, and that's all the children. And we want to add ours to the set of things it contains. Okay, so it doesn't contain actually anything. It says get me the bucket, add our thing to the bucket, but the bucket's called children. So get the children, add our thing into it. Okay, that's all that means. So we're going to say hello world, that's going to be our text, and then we can do stuff like set the font, hi.setFont. There we go, and we can give it a font like font.font, and we can specify a font name like that, and we can add a font weight, like whether it's italics or whatever. So font weight, there we go, black or normal, whatever, it doesn't really matter. And then the font size, we can say 40 point, oops, not 390, that's fairly big, like that. So now we've got ourselves a piece of text in a particular font. That's just a standard font that's on many operating systems. And then we can set a color for the font, like that, and we'll say color.red. Wait, let's call it something different. Let's choose a different color. What, Azure, okay, whatever. You could call it whatever color, you can make it whatever color you like. Really, it's totally up to you. And then what we will do is we will write these words and put them on the stage. So say root.getChildren. Again, someone asked what this getChildren is. It says find the container for all the objects in the root and add this one to that container. Add hi, okay? And now we'll run our thing. We should see hello world. Now let's see what happens. Okay, now you're not seeing anything. Well, why not? Because I've run the wrong thing. Have I? Oh yeah, let's call this hello world to start with. Call this hello. All right, run it again. And you probably still won't see anything. So let's see why. Okay, now if you look really carefully, you squinted, you might see something up the top there. What's going on is our stuff is off the screen. And let's run it again one more time. Notice the stuff you see at the top there is blue, Azure in color actually. There's a very thin blue line there of Azure. And what's happening is our hello world is sitting right at the top of the thing. How do we change that? Well, we could go and fiddle exactly what pixels the hello world went to, or instead of using just a random old group thing here like this, we can use a thing called a stack pane, which automatically puts things centered nicely for us. So we're going to do that. We're going to say stack pane, there it is, scene equals, oh, hang on, not the scene, the root is what I wanted to change, stack pane. There it is, equals new stack pane, like that. And just by doing that, we've now, instead of putting it in just an arbitrary container, we've got a container that organizes stuff inside of it nicely. So let's run this and hopefully we'll see our hello world. No, we don't. What have I done wrong? Oh my goodness. Let me see here. Set the new scene, set the font, set the fill. Add hi. What have I done? My goodness. I cannot see the issue here. What is wrong with it? Oh, yeah, very good. It's there. Someone's noticed it. It's incredibly light. It's just here. It's there, but very light. That's my bad for choosing a bad color. Okay, let's change this color. That totally got me. Okay, let's change this color red. Run it again, and hopefully this time you can actually see it. Right. It was so light that I couldn't see it. Oh, that's better. Okay. All right. There it is. It actually worked. It was just a color, a fairly unusual color. Azure was. I didn't realize Azure would be that light. All right. But what we can do a few other little things here. We can change the opacity and stuff like that. So we can say hi dot set opacity, and then give it a number like 0.5, for example, and then that will make it a faint red because it will actually do the red slightly transparent. Okay, so let's just have a look now, and it'll look pinkish probably. Yeah, and that's not actually pink, it's actually transparent red. Okay, but we can also do cool stuff like make the actual window transparent, and the window is the stage, remember? So we can say stage.set opacity. Oh no, I didn't want to do that. Opacity, there it is, and make the window transparent, and as long as your operating system supports it, you get a transparent window. There it is. So we have a window that's transparent. You can read the code behind it. All right. Now, we've got just enough time to race on. I'd like to race through this next section. It won't take us too long. We will probably go slightly over time, but not much. Okay. We've got a key idea. No. You guys are tired, I bet, because you've been working on the assignment. We'll do the next part on Monday. It won't take us very long. It'll probably only take us 5 minutes. But let's skip over it and do the bio and give you guys an early mark. You all want to have a long weekend. Well, not a long weekend, but you want to have a rest this weekend because you've been working hard on your assignment. So let's skip over. This is actually a fun. X2 is actually fun, but we'll skip over it today and jump instead to our bio and then finish the lecture ever so slightly early. So our next bio is Jeanette Wing. Jeanette Wing is an amazing computer scientist. Oh my goodness, this is out of date. She is now at this slide. I thought I'd updated this slide. What's happened here? Okay, she is now, I believe, dean at Columbia University. She was head of Microsoft Research International. And she is responsible for many big ideas in computer science. One of the ones she's well known for is a thing called oh god, I've suddenly got a mental blank here. It's not even on the slide. What am I talking about? Yeah, computational thinking. Have you ever heard of computational thinking? Computational thinking was something that Jeanette Wing coined. And she is a very inspiring person as well. So she's a very accomplished person. Interestingly enough, she is the former student, I believe, of one of our Turing Award winners, who we'll come up to later, and Barbara Liskov. And Barbara Liskov and Jeanette Wing worked on an idea that I've already explained to you. It's such a fundamental idea, and that is the relationship between state and behavior, and them being key ideas in an object. So Jeanette was part of that. Alrighty, I think with that we can finish the lecture. Have a great weekend, and I'm going to have a quick catch up in a short while on I think on Zoom with our student reps. So with that, have a great weekend, and I'll see you on Monday.